This video shows the techniques used to restore hollow wooden sailboat masts that are glued up from two pieces of wood. The 23-foot long hollow Sitka spruce mast shown in the video belongs to a 1963 Wayfarer sailboat that was built in the UK. The mast was most likely built by Collars in Oxfordshire, England, who still make Sitka spruce Wayfarer masts today. The mast was glued together in two halves, probably glued with Aerolite 306, a urea formaldehyde adhesive developed for building wooden aircraft during World War II. Over the 55 years since it was built, the adhesive began to deteriorate in the luff groove where it wasn't protected by varnish. Eventually, the glue joint began to let go, and then when the mast was wet and the wood swelled up, the luff groove would open up to the point where the leading edge of the sail would fall out. At some point in the mast life, the original Tufnol and bronze halyard sheaves had been removed, and the mortises for them had been enlarged to take modern sheave inserts. Luckily, the original sheaves and axles had been kept. When the mast came in for repair, the owner asked for the sheaves to be put back as they were originally. Here's how it was repaired. Step 1 was to measure the mast and make a scale drawing. Scale drawings for spars are typically drawn with the length compressed as shown here. The scale drawing was used to lay out a set of supports for a jig that would be built to hold the mast in alignment during regluing. Step 2 was to separate the two halves of the mast. Steam was used to soften and release the glue joint. To make the steam, I used a 10-gallon plumbing system pressure tank from the scrapyard on top of a propane burner from a turkey deep fryer. Initially, I made a sort of steam blade out of copper sheet, which I thought would be useful to direct steam right at the glue line, but it turned out to be ineffective. It just didn't deliver enough steam. What worked was putting the halyard holes directly onto the outlet pipe of the boiler, so that steam flowed through the hollow center of the mast. I put blankets over the mast to contain the steam and just kept heating the entire mast with massive amounts of steam. I used spruce wedges to ease the glue joint open a little bit at a time. The square base of the mast isn't hollow, and it wouldn't separate until I put a garbage bag over the end to contain the steam and thoroughly heat the wood right through. The glue slowly softened and released the two halves of the mast from each other. The released joint faces were as smooth and clean as the day they'd been glued up. The builder's penciled reference lines looked like they'd just been drawn. There was no glue residue or squeeze out visible at all. Except for a small amount of water damage, the wood inside the mast was like new. Step 3 was to make the two halves of the mast good again. There was a split inside the luff groove that was repaired with a Sitka spruce spline, epoxied in place. After the epoxy cured, the groove was recut using a core box bit and a laminate trimmer router, fitted with a base and a fence. The mortises for the halyard sheaves were repaired to take their original sheaves. The halyards are wire spliced to rope. Wire has less stretch and weight, and rope is easier to pull on with your hands. So the peak of the mast has small bronze sheaves for the wire end of the halyard, and the base of the mast has larger Tufnol sheaves for the rope end. The peak sheaves have Tufnol sleeves that they fit into, and the base sheaves have a Bakelite divider between them. The enlarged mortises were filled in with bits of Sitka spruce epoxied in place, and then recut to fit the original hardware. Step 4 was to prepare the two halves for regluing. The mating faces of the two halves were lightly skimmed with a sharp jointer plane to clean off any glue residue and ensure a good fit of the mating surfaces. Step 5 was to set up the gluing jig. The gluing jig was set up using a laser level shot through multiple reference points. For center line and height alignment, each support had a hole drilled below the center line of the mast notch. The supports were tweaked until the beam of the laser level could be shot through all of these holes from end to end. For removing any twist, This target jig made out of a piece of scrap was used to bring all of the top surfaces onto the same plane. The extra width of the gluing supports provides a work surface to support the mast pieces while preparing them for glue up. Step 6 was to glue the two halves back together again. The mast halves were masked along the edges of the glue joint to save cleanup time. The inside edges of the gluing jig were also masked to prevent the mast from adhering to the supports. The mating surfaces were wet out with West 105 resin and slow hardener, then brushed with a thin coat of 105 resin thickened with microfibers. The two halves were pulled together with zip ties and then slid into the jig. Light clamping pressure was applied with C-clamps, and then the mast was left to cure overnight. Step 7 was to clean up after the gluing job and apply a sealer coat of varnish. After gluing, the mast was lightly planed and sanded, and then a sealer coat of spar varnish was applied. Messenger lines for future halyards were fed through the mast using a vacuum cleaner prior to installing the original sheaves. Step 8 was to reinstall the halyard sheaves and cleats. The original bronze axles for the halyard sheaves were completely worn out. Replacement axles were made from silicon bronze carriage bolts turned down to the correct diameter by using a drill press as a lathe. Once the sheaves were in place, the axles were locked in place by peening the ends with a ball peen hammer to swell them out a bit. With the cleats reinstalled, the mast is ready to be picked up by the owner, who will complete the varnishing and re-rigging. With regular care, this mast should be ready for another 55 years.
Thank you for watching. Like and subscribe.